Lesson 12.3, absolute value inequalities graphically. So these first two problems are actually going to be from a timed section, but I want to tell you how easy they are once you know what you're looking for. So the directions just ask, what is the solution to the following inequalities? So we've got this problem right here, which looks familiar because we actually solved absolute value inequalities on the last lesson. But if I were to graph it, they're not solving by moving the -7. They're keeping it where it's at, and they're actually making this a function, y equals negative times absolute value of x minus 3, then minus 2. And so I wrote it in purple. That is this V shape right here. That's been flipped upside down because of the negative. It's shifted right 3, down 2, and there's the vertex. But you don't really have to worry about how it's graphed. You just need to know that's what that is. Then they have really just y equals -7, which is a horizontal line going through the y-axis at -7. They're asking us, where is this absolute value part less than -7? So when you think of a less than something, it needs to be below. So if I were to look below this horizontal line in red that I have, I can see my absolute value is going to be here at this endpoint or this ray and here. It might also help if I shade vertically, kind of like when we talk about domain and range, because I want to know the x values. So I'm going to shade this way. So if I were to look at this as a number line, I see that x values are 8 are bigger. That's where this ray is. And then this side is where x is less than or equal to -2, this way. And it's an or. That's really all I need to know, is that it's an or, not an and. Okay, let's try another one. I'm actually going to have you change the symbol because I meant to get an and problem. Let's do is less than. So again, this is graphing the absolute value of x plus 5 minus 7. That's the V-shaped graph here. And then leaving it with the -5 on the other side means graph the line y equals -5, another horizontal line. Okay, where is our absolute value less than the number? This time, because our absolute value graph opens up, less than the red line is just going to be this little triangular shaped piece, which is between two x values. So this would be an and. We're saying x's are between -7 and -3, which would be the second option. So once you know what you're looking for, it becomes pretty quick. Okay, let's try some on our own. It says use a graphing calculator to solve the inequalities. You could also pull up Desmos if you wanted to, but I'm going to show you how to use your graphing calculator. Go ahead and pull up your y equals to put a graph in, clear if you've got anything in there. This has to be 4, and then times the absolute value. You don't have to hit times, but absolute value bars are going to be found under math, and then over to number, that's what num is, and then the ABS, the abs. My calculator is a little newer, so it'll bring up the bars. Some of yours will bring up parentheses. It's the same thing, but then you're going to put in x minus 5, arrow out of those bars, plus 5. That's all you want to put in for your y1 is just this left side. So we're saying, where is this absolute value part less than 29? So we're literally just going to put in y2 equals 29. Then hit graph. But the thing is, if this is y equals 29, that's going to be a horizontal line up at 29. So I'm going to probably have to change my window. X min and max should be good to stay -10 to 10, count by 1. Y minimum should be good, and it looks like I already changed it. I'm going up to 30 to fit that y equals 29. I could even go higher, like to 40, and I would count by bigger, something bigger than 1, like 2 or 4 or something. Hit graph. There's my absolute value function, and then there's where y's are 29. We want to know what part of this graph is where y's are less than 29. And so I see I don't even know what this other side is, so I might go ahead and go to window again and change my x max to 20. Let's count by 2s and see if that gets it. And it does. So I need to know where these two lines intersect, and then I see that my absolute value graph is below the line here where it's going to be between these two x values, so it'll be an and. So I'd go second, calc, find an intersection, number 5, It's going to flash a point and it's going to ask you, is it on the first curve? Yes. Is it on the second curve? Yes. And then guess, you have to hit enter one more time and it'll pull up, it actually did this point for us, 11, 29. And so again, I've got this doing this. I've got a line here. This point is 11, 29. Okay, I'm going to do it and find the other intersection point over here. So you got to go second calc again. Number 5 for intersect. Flashing, I want to get over closer to this point this time. So it knows I want this one. Somewhere in there is good. And then same thing, I'm going to get on this left side of the intersection point. Okay, that tells me that's at -1, 29. Makes sense that the y's are 29 there because it's literally intersecting at y equals 29. And so I would say it's all of these answers in here. That would be x is less than 11 and greater than -1. Okay, I have so much space here because I contemplated showing you that you could solve this like we did in the last lesson and get these same exact answers, but I think I'll wait till the bottom too. Because sometimes I think that's faster to just solve than graph. But let's try another one. Number 2, you need to put in this part for y1 and then just -68 for your y2. Should look like that. Remember, you go to math, over to num, and then absolute value is just option number 1 when you need it. And then your y2 should just be the -68. Now, knowing that this has to go through the y-axis at -68, I'm definitely going to have to change my window to where my y's go really low. So I'm going to go down to -70. Oh, whoops, that's my max. -70 for my y min, y max just 10. Let's count by tens. Let's see what that does. So I can't see this point of intersection over here. I'm going to have to make my y's be smaller. Oh, not second count. Window. Did I say y's x be smaller? I don't know what I said. Let's count by 4s. As long as I can see the 2 points of intersection, I'm good. Almost off my screen, but I can see it. So it's where is this absolute value function smaller than y's are -68? That would be these two pieces that are going away from each other. So this would be an OR situation. So go second calc, number 5, first curve, you can see it here, flashing, anywhere in there is good. Second curve, it's kind of hard to see, I can see it down here. I'm gonna go to the left again, that seems like that likes it like that. That is, oh shoot, I think that was what, -16? Yeah, it looks like -16, -68, and then the other point of intersection is at 14, -68. And again, you could use Desmos, that would be probably faster, but then you got to pull up 2 different screens. And we said this was an OR because our absolute value graph is doing this, and then we have a horizontal line here, and we wanted where is it less than. And so it's this way to the left, oh, that was really sloppy, sorry, and that way to the right. So I would say x's are less than -16 or x values are greater than 14. Okay, 2 more. These are multiple choice. Right away I can use what I know about, hey, the absolute value is isolated and it's less than a number. That immediately tells me it's an AND problem. And so I can take out the ones with the ORs. It's just now a matter of figuring out what the solutions are. You could graph again. You could look at Desmos and graph again, or I could just straight up solve this, where I take out the 5x plus 3 less than or equal to 8 and 5x plus 3 greater than or equal to, remember, flip the symbol and make the 8 negative to solve. So it'd be x is less than or equal to 1, which automatically tells me it's this one. If I wanted to solve the other one, I would get negative 11 fifths, which is what x is greater than. So that one it is. Same thing with number 4. I would see that, hey, this is isolated and I see greater than. Greater means it's an or problem, so I would take out any ands. And it's got to be this or this. You could even make these equations. Remember, you're just changing then the 8s to a negative 8 and figuring out what the solutions would be. Since we know it's an or, subtract 11, that would be negative 3 divided by 3. Even though we would be flipping, oh no, we're not dividing by negative. Never mind. So we get negative 1, which immediately tells me it's this one. X would be greater than or equal to negative 1. And then less than or equal to, but I would get the other one to be what? Negative 19 thirds. So it's that one.